In this video, I'm going to explain to you how a basic floor plan can be constructed and then how we can use this to create an elevation view that's associated with it. So I'm going to talk to you first about what you're seeing on this floor plan and how it's drawn. And then we'll show how to carry the lines up to create an elevation. And then I'll go over some details about how to create textures and annotations. So just to begin, it's really important that on the lower left-hand corner of any drawing that you create, there's a drawing label and a scale. And as well, we need a north arrow too. So on this bottom drawing, we can see that it's a floor plan and the scale is 1/2 inch. And that's because 2 squares on the graph paper equal 1 foot in real life. We also have a north arrow here, and that's so that we can refer to walls by their cardinal direction. And that's, again, pretty standard to find in the lower left-hand corner. Normally in a floor plan, you would see door swings. You would show the door opening up at a 90-degree angle to the wall here, but I was trying to draw this floor plan as large as I could to fit on the paper to get a nice level of detail on the elevation. So we did not have room for the door swing, so I omitted them here. You can see that the walls are filled in with solid black lines, which we call poching. And you can see that the windows are drawn by showing a series of lines, especially these 2 center ones here that indicate the panes of the glass. On this floor plan, you can also see a couple of other things. You can see a line that would indicate a shelf here, which we'll see on this drawing above here. And then you can also see the symbols for a sconce here, which refers to these sconces up here. You can also see a series of little itty bitty dashed lines here, and those are indicating what would be hidden, and that's referring to these brackets that are right here. So the floor plan itself is pretty basic, but one thing that you may not recognize is this elevation tag right here. And an elevation tag is constructed by creating a circle and an arrow that's filled in, and the direction of the arrow indicates which direction you would be looking. So if I'm standing right here and I'm looking in the direction of the arrow, this is what I would see. So the way that you construct an elevation, and you can see here there's the elevation tag on the lower left-hand corner, or pardon me, the label, and you can see it corresponds to this A here. You've got the same scale. You can see I've got a ground line, and the ceiling height is 8 feet tall. So once again here, 2 squares represent 1 foot in real life, and so the scales are the same. So the way that we begin creating an elevation is by carrying lines upward where we would see walls. So you can see here the very edge of this wall where my mouse is. If I carried that line vertically straight up and started at the ground line and it went all the way up to the ceiling line here, you could see that that would create the little wall on that plane. You can see here it's the same, and these are both symmetrical, or they're supposed to be. So you can see that that's carried across over here. You can see that I've drawn the little thickness of those brackets, and those lines have been carried up here and here. Up. The center line of the sconce aligns with the center line right here. So all you're doing is just kind of breaking up the planes of this elevation first by drawing the lines of the architectural features. And then from there, all I did was determine the profile line that I wanted for this cased opening to be. You can see I've got a floating shelf here, a countertop, and some doors. And these are just basic cabinet doors with a little mesh background here. So you can see my texture lines are a little bit lighter. They're in my thinnest line weight pen. And then the rest of the lines are drawn in about a medium line weight pen. So once you've got the basic form and you've got the textures and details drawn out, next it's time to do some labeling. I like to start by labeling on one side of the drawing, so it could be the left or the right, but you can see here on this drawing I have the labels on one side and I've got the dimensions along the top and on the opposite side. Because if I were to have the dimension line over here as the notations come out, there would be a lot of overlapping with what they call leader lines, which are these little lines here. The leader lines would overlap with the dimension lines and it would get really confusing. So you want to pre-plan this and have the dimensions on one side and the notations on the other side. Now, this looks pretty good. There's the least amount of overlap as possible. But just keep in mind, I wrote this in pencil first. It didn't come out perfectly the first time I did it. So I had to plan and make sure that I labeled objects to reduce the length of the leader lines, and then also to make sure I got every texture called out with my notations without too much, scribbling and overlapping, and making sure that everything fit really nicely. But you can see here every material and surface and object that's on this drawing is called out. And there's, just sort of a generic level of detail, but enough that would give the client information and perhaps the cabinet maker information about what we would need to construct this and to give us an understanding of some pricing. You can see here, as we move on to the dimension lines, I have straight lines horizontally and vertically. You can see that there's this little, what they call an architectural tick mark, which indicates where the dimension stops and starts. So you can see here, I've got the most detailed dimensions closest to the drawing and the least detail going outward. So this is the overall dimension here. You can see it's 17 feet 0 inches, and there's an architectural tick here and an architectural tick here. For this second dimension line, we can call these the interim dimensions. And these are, again, critical. You can see here that there wasn't enough room for me to fit the dimension in between those two architectural ticks. So I did another little arced leader line coming out. So that's 0 feet 6 inches. And you can see there's an architectural tick from here to here. And that dimension is there, 2 feet 0 inches, 2 feet 0 inches here. The same thing, I didn't have enough room, so I had to do a leader, and then you can see here 7 feet, and it repeats on this side. One thing that I do want to draw your attention to right now is the format of our dimension lines and our dimensions. You can see here that it's written in feet and inches, and that's really, really important because there's errors that can happen if you're not consistent with that. So you can see here it's feet and then the foot apostrophe, a hyphen, and then the inches with 2 apostrophes here. Notice you also have trailing zeros right here and leading zeros right here. So you wouldn't just write 6 inches or 17 feet. You have to write 17 feet 0 inches, 0 feet 6 inches. So trailing and leading zeros are a critical part. So as you dimension, I want you to follow this format as well, because it's an industry standard. You can see here along the side, I also have the overall dimension, and then I have a series of interim dimensions here. You can see that I've called out, instead of the distance from the countertop to this shelf, which might be a critical dimension, you might think, it's easy to see that it's 18 inches up because, again, each of these boxes represents 6 inches. But what I actually called out instead was the location of the J box, because that's more important for someone who is constructing this in real life, because they're going to need to know where to pull the wires out for these sconces. So as you see, as you look at this, notice that I'm trying to give whoever is going to be building this or paying for it information about sizes and where components are going to come out and meet the walls or have things brought out or to them, or where a series of finishes are going to intersect. So there's a method behind annotations, most certainly. You can see I also have noted that this is open to beyond, because of course that it is open to a room that's located back here, but we don't want to draw all that because it can be confusing. Finally, you can see I have a scale figure here, and this is important because even though we have a scale drawn here and we know sort of how big this thing is, it can be very helpful to bring in a person so that we can see how the height and reach range of a person might interact with the size of this piece of furniture. What you do need to realize in drawing a scale figure, even if it's your very first time, is that the eye level for a woman is usually about 5'6". So you can see here, that's how I calculated this. Notice also I've tried to give a somewhat realistic body shape. The head is an oval as opposed to a circle. The shoulders are 3 times as wide as the head. Instead of, and I'm just giving a very general suggestion of body parts here. What we don't want to see is this, ice cream cone shaped person where you've got a perfectly circular head and then this inverted triangle for the body, because that doesn't really give us any information. So use this scale figure as a guide if you'd like, or you're welcome to create your own. But those are the steps that it takes to create a floor plan and then derive an elevation from it simply by carrying up the lines. So that's what I did first. Then I came in and added textures and details, and then I added in the annotations over here and the dimension lines along the top and side, keeping in mind, of course, that we want to be as neat and mechanical as possible, and also do a little bit of pre-planning, or you may have to do several drafts to make sure that everything lines up, looks beautiful, and is not overlapping.